This is our overview of the project. First of all, visual prototype. We are using SolidWorks as a main platform to fully build the product. We should have mechanical elements in our project. However, electrical or electronic components are allowed in minimal, but the model expects to work more on the mechanical modeling process. Next, we should have at least minimum of 4 components. And then, no size limits. It can build as big as possible, but should be reasonable. Lastly, move based on animation or modeling to present how to use the product and how it works. Now, we will present you our design objectives. Firstly is to move heavy and big stuffs as well. Secondly is to save the time and energy. Thirdly is to protect the quality of stuff while using the lifter. Last one is to prevent from unwanted injury. We have 3 scopes of project. First of all is literature review. The valuable data are searched and gathered, such as looking at an existing trolley at the market right now, considering the shape of the trolley in terms of its complexity and the method to produce. Next, we move to the sketching and designing. Using the concept general method, the morphological chart is used to generate alternatives. Select and combine the design concepts and options from the complete morphological chart. Sketching and designing a minimum of 5 drawings based on selected morphologies. For sketching, we are needed to illustrate the rough graphic layout as it shows all the important parts of our product, multipurpose lifter. Besides, the product architecture is shown as it presents the machine working flows. We apply the given knowledge as SolidWorks software will be used in creating the design of the multipurpose trolley. Our last scope is SolidWorks simulation. We use SolidWorks software to show people how the multipurpose lifter works by using simulation skills and techniques. Hence, high skill and understanding needed to show and convey how the trolley works via SolidWorks simulation. Behind of this project surely has its reason. Why is it important to develop a mechanical item that will benefit all consumers in their daily lifestyle? Basically, the aim of multipurpose lifter is used to lift the heavy stuff and transport a material to another place. The function is like a forklift, but in small size where the consumer can store it at a small space at home or storeroom. So, people do not have to worry about the problem on how to store the lifter in good condition. So, the implications of our multipurpose lifter is, first of all, help people doing their job. Secondly is increase the safety of the consumer. Thirdly is improve consumers' daily lifestyle. This is for our project planning. First of all is assign team. Building team from various skills of members. Our team consists of 6 members. Next, brainstorming. Each of members study the given theme and comes up with good ideas during the discussion time. The third one is concept generation. Team was asked to arrange the ideas obtained into morphological chart. Fourth, embodiment and detailed design. the specification of the design dimension. Then, fabrication of prototype, technique and tools as SolidWorks used to get better finished product. The last one is testing and improvement. Test the simulation of product and improve the weakness.
Problem statement. Lifting heavy and big stuff such as furniture become a problem to housewives, office workers, and storekeepers. Injuries can easily occur while doing lifting work as they are not in proper positioning during lifting the items. A lot of energy and time wasted, especially when a housewife who must clean up the whole house.
The problem identification is trouble in handling heavy jobs. Therefore, there are 5 main parts of multi-purpose lifter as well as their function. First, body frame to support load and move lifter. Second, tray for carrying load. Third, pedal for controlling the hydraulic cylinder moving up and down. Fourth, to lift the tray up and down. And lastly, the triangle stabilizer to avoid any unwanted injury on consumer.
Customer survey. Our survey include their age, gender, prefer mechanical device or human strength, does mechanical device save time, does multi-purpose useful or not, and the last one, does human strength require a lot of energy? This is customer requirement. Safety first, compartment, and lightweight material. Product design specification. Performance used to lift heavy things with medium size. Economy, affordable and reasonable price. Competition, general product used by most of the people. Service life, long lasting. Environment, no corrosive fluid and harmful chemical used for product material. Weight, product will vary from 5 to 7 kilograms. Maintenance, small maintenance on the wheel if the wheel is not running smoothly. Material, steel hollow bar. Wheel, hydraulic jack. Testing, test on maximum load, which is 100 kg. Safety, a safety operational video will be given. For the size, our maximum height 1.1 meter. Quantity, our target sales 500 per year. Product lifespan, stay in market for about 3 to 4 years. And last but not least, limitation, not too compact because cannot be foldable.
Literature review.
Type of existing trolley.
I-drop compact folding aluminium frame hand truck trolley. Heavy duty 2 wheels trolley. Climb stair hand truck trolley.
Morphological chart. First, body frame. we have 4 design of frame sketched by our team member. Second wheel, we have 4 types of wheel: rubber wheels, leather wheel, threads and duals. Lifting mechanism, hydraulic or pneumatic cylinder, belting, chain and scissor lifter. For material, we have aluminium, stainless steel, carbon fiber, high density polyethylene or HDPE. For small compartments, we have canvas, steel box, plastic box and component holder. And for control mechanism, we have lever, pedal, button and pulley. For safety, we have straps, clamp, suction cup and elastic band. Moving mechanism, we have 4 types of moving mechanism: 2-wheel, 4-wheel, foldable front wheels and conveyor.
For concept 1, concept 2, for concept 3, concept 4, and the last one, concept 5.
And this for perf chart analysis. Based on this perf chart analysis, we can conclude the best design for our project, which is design 4. It is because design 4 has the highest net score, which is 24, and the most portable compared to the others design. However, the lightweight is negative, but the design still can be improved.
As for the design layout, there are 5 main parts, which are handle, tray, pedal, wheels and hydraulic lifter. This is our design layout from the side view. The calculation on the critical part is on the tray part. We need to look for the load applied and normal stress in order to find allowable stress.
Next is the engineering analysis. Stress analysis. For simulation study, we have chosen the most critical part of our project that have to accommodate the highest load among the other parts. The load that applied to the part is 981 Newton. The simulation has analyzed for characteristics of the part, which are stress or von Mises stress, displacement, deformation and safety factor. The von Mises stress is a value that used to analyze if the material such as metal will yield or fracture. First and foremost, for stress analysis, the highest von Mises stress is 3.207 times 7 Newton per meter square. This happened on the fixed location upper and bottom surface. The yield strength for this part is 1.724 times 8 Newton per meter square. The value of the highest von Mises is lower than the yield strength. The probability for the structure to fail is low and the structure will be functioned properly. Next is the displacement analysis. The red color represents highest displacement when loads is applied. The magnitude of highest displacement is 7.972 times -1 mm. The highest displacement happens at the end of the tray part. For the third analysis is strain analysis. Strain usually happen at the highest stress and have the same location. The highest strain is 1.053 times -4. The last analysis is safety factor. The lowest safety factor for the part is 5.374. This meaning the highest load it can support before fail is 5,271.89 Newton. This lowest factor of safety happens to whole part. The safety factor is safe for the product and can withstand the load until 537.4 kg.
Parametric design, body frame. Tray. The third one is pedal. And the last one, triangle stabilizer.
Next, there are 29 of detail drawing for every part. This is the sub-assembly drawing for the body frame. This is the sub-assembly drawing for the both pedal. This is the assembly drawing from the top view, front view, side view, and isometric view. This is the exploded view drawing. This is all the bill of material from the exploded drawing.
Bill of materials. Part number 1, hollow steel. We use IC304 stainless steel with two different lengths, cost 79 and 68 ringgit. Both 6mm in thickness. Part number 2, steel plate. We use IC316 stainless steel with two different in length, cost 19 ringgit. Part number 3, steel sheet. We use SS304 with 3mm in thickness, cost 12 ringgit. Part number 4, hydraulic. We use Koki 2.5 ton low profile jack, 85mm to 380mm, cost 150 ringgit. Part number 5, rubber caps. We use two different in size of rubber caps. First 200mm times 100mm, 2 in quantity, and the second 100mm and times 100mm with 4 quantity. Each cost 1 ringgit and 50 cents. For part number 6, steel rod. We use IC304 stainless steel with two different in size, and the first one cost 17 ringgit and the second 15 ringgit. For part number 7, steel square bar. We use IC304 stainless steel with cost 20 ringgit. For part number 8, rubber sheet. We use fabric texture surface rough waterproof anti-slip, cost 10 ringgit. Part number 9, nuts. We use stainless steel hex butt M5 times 0.8 with 8 quantity, each cost 1 ringgit and 75 cents. Part number 10, caster wheel. We use STC free wheel, 2 in quantity and each cost 6 ringgit. For part number 11, wheel. We use Tentra rubber wheel, 2 in quantity and each cost 25 ringgit. For part number 12, steel block. we use IC304 stainless steel, cost RM22. Part number 13, strap. We use protector anchor strap polyester, cost RM38. And part number 14, rivet. We use aluminium alloy with 4mm in thickness. It costs RM5 per box. And the last one, bolts. We use stainless steel M5 x 0.8 with 8 in quantity. Each costs RM2.40.
As for costing evaluation, the total variable cost that we get is 578.20 cents, and the sales price per unit is 700. Since that, the profit per unit that we gain is 121.80 cents.
Break-even analysis. This is our break-even chart.
Manufacturing detail. For body frame part 1, the steel hollow bar 200mm x 100mm is cut into 2 pieces with the measurement 1100mm each for the steel hollow bar purchase. For the body frame part 3, the steel hollow bar 100mm x 100mm is cut with the measurement 180mm long. For body frame part 4, the steel hollow bar 100mm x 100mm is cut into 2 pieces with measurement 720mm each. For body frame part 5, the steel bar 40mm x 100mm is cut into 2 pieces with measurement 1000mm each, and the hollow section in the middle of the steel bar is removed with measurement 800mm long and 30mm depth by using milling process. For handle part 1, the steel rod with measurement 410mm and radius 30mm is purchased, and the middle of the part is removed by using milling process. For handle part 3, steel plate with thickness is cut with measurement 117.70mm x 50mm. For handle part 4, the steel block 70 x 70mm is used and a 50 x 50mm is cut at the other end. For compartment, the steel sheet is cut into 500 x 200mm into 2 pieces. Then for another face, we cut the steel sheet into 100 x 200mm for 2 pieces. For pedal T-joint with dimension radius 10mm, 110.8mm long and 60mm wide. For pedal part 1, 10 x 11mm steel hollow bar is cut with a length 21mm 60° incline. For pedal part 2, 10 x 11mm steel hollow bar is cut with a length 180mm with parallelogram shape. For pedal part 3, a pentagon shape with thickness 2mm is cut using steel sheet as the material. For pedal part 4, 10 x 11mm steel hollow bar is cut with the length 30mm, a radius 10mm at the other end. For pedal part 5, 10 x 11mm steel hollow bar is cut with 180mm with 30° incline. For tray part 1, 665 x 650 steel sheet is cut with pentagon shape with desired measurement. At the end of the side, a hole is made with the radius 5mm. For tray part 2, 650 x 240mm steel sheet is cut and a hole with a radius 5mm with a distance 125mm from each of the end of the side. For tray part 3, a steel block 100 x 100 x 50mm is cut with depth 30mm, and at the left at the center will be filled. For tray part 4, a steel sheet with 5mm thickness is cut into 400mm x 30mm dimension. For triangle stabilizer, a steel block 140 x 190 x 250.55mm is cut with trapezium shape. Product manual. For upper body frame, Part 1 and Part 5 is welded to make a H shape. Then, the both Part 5 is joined at the center of body frame. For lower body frame, Part 2 and Part 2 is welded together. To assemble the upper and lower body frame, the part will be welded and a hole with diameter 25mm is made to insert a shaft. For tray, Part 1 and Part 4 is welded and the Part 2 is joined by a shaft. Tray Part 3 will be inserted first into the body frame. The tray Part 1 and Part 4 and Part 2 will be welded with Part 3 to complete the design. A hydraulic lifter will be placed on body frame Part 2 and welded together. A complete assembly of pedal will be put at the end of the hydraulic lifter. A complete assembly compartment will be placed at the side of the body frame using rivet as the joint. Straps and hooks we purchased will be put at the side of the body frame for safety purposes. A body frame shaft is inserted through the hole that made at the end of the body frame to place wheels. For front wheels, 4 holes will be drilled at the both body frame Part 4 to join using bolts and nuts. Then, front wheels will be placed at the holes made. Triangle stabilizer will be placed at the end of the back body frame and will be welded together. Rubber seals that purchased will be put at the hollow of the body frame to increase the safety. Exploded view for this multi-purpose lifter. Front view. Side view. Top view. Assembly animation for multi-purpose lifter. To increase the height of the tray or to lift up loads, the right pedal will be used. After lift or place object according to the desired condition, the lifter can be moved front and back by using human force. To decrease or to lift down load, the left pedal will be used.
In the conclusion, the product achieves the objective. This product design is that the team learned how to apply the theoretical learning into the practical by designing a product. The multi-purpose lifter was made to help people doing their job. The recommendations of our project: in the future, Choose the material that can withstand the necessary load without failure when choosing the material of the component. For example, steel or any metal, and must take a change if needed. For further recommendation is to design 6 wheels to allow the lifter to climb the stairs. People often experience lower back injuries and other discomforts from carrying heavy loads upstairs. Besides, the next recommendation for our future work is to design our handle with adjustable handle height. This feature can make it easier for users to adjust according to their comfort and height. Thus, this trolley is suitable for all users despite having different heights. Finally is to make this trolley become lightweight. This may be changed by changing the material used, for example aluminum, or changing the shape or size to be more compact. Aluminum is a material that rust resistant, so it will last a long time.